Welcome to this explainer. If you've ever waited months, sometimes in total agonizing silence, for a peer review, you probably know that the academic publishing system can feel, well, fundamentally broken. I absolutely love unpacking complex systems and finding the hidden mechanics that make them tick. And today, we have a really fascinating one for you. We're going to explore the economics of scientific publishing, and specifically, we're focusing on a 2026 working paper by Johan Fourie titled The Price of Submission. This paper takes a magnifying glass to the massive, often invisible pressures building up inside academic economics journals. It combines a really rigorous data census with a theoretical model of exactly how authors behave when they're trying to get published. So, what is the true price of submitting a scientific paper? When we think about the cost of getting published, it's incredibly tempting to just look at a dollar amount on a journal's website and leave it at that. But the true price? It's way more complex. As we'll see today, it isn't just financial. The real price is actually paid in time, in agonizing months of waiting, and in this systemic congestion that literally strains the entire academic ecosystem. Okay, let's lay out the roadmap for Explainer today. We're covering 1, the academic publishing squeeze, 2, the journal fee census, 3, tracking rising submission costs, 4, time versus money, 5, the submission cascade, and finally, 6, system-wide pressures. Let's jump right into Section 1, the academic publishing squeeze. To really understand this squeeze, we first have to recognize that the scientific publishing system is under severe strain right now. Basically, article output is rapidly outpacing the available supply of careful, rigorous peer review. And the data we're looking at here brilliantly illustrates exactly where this pressure is coming from. We're tracking new papers from 2020 all the way to mid-2026. Now notice that vertical dashed line right down the middle. That marks the public release of ChatGPT in late 2022. Look at the stark contrast between the lines after that point. That dark plumb line shooting upward represents archive economics postings. Now, Archive is a platform where posting is entirely open to anyone, and you can see it is visibly surging, growing by 0.28 log points in just the year leading up to June 2026. But then, look at the flat blue line at the bottom. That represents NBER working papers, which are gated by institutional affiliation. So the big takeaway here is undeniable. Explosive growth is happening precisely where access is open, which is flooding the system with new manuscripts, while those gated communities remain entirely flat. But we really need to be precise about what is actually bottlenecking the system here. A journal's capacity isn't measured in raw submissions. Let's be real, editors can generally handle the influx of digital files. The true, incredibly scarce resource we're dealing with is the completed referee report. See, once a manuscript survives the initial editor's screen, what they call desk triage, it has to be sent out to external experts. Every single paper needs multiple completed reports to be validated. And that, right there, is the actual bottleneck where the system is breaking down. Moving on to Section 2, let's look at the journal fee census. So how do these journals actually manage this absolute flood of demand? Well, a lot of them use pricing. And mapping this landscape of exclusivity reveals a pretty stark divide. What you're seeing here is a July 2026 census of the 500 highest-ranked economics journals. Look at the top panel. It's like a barcode that orders these journals by rank, highest on the left, lowest on the right. Every single plum-colored tick mark is a journal that charges a submission fee. Notice how insanely dense that plum color is on the far left among the elite journals? Then, if you trace the percentage of journals charging a fee in the bottom panel, that plum line starts incredibly high on the left and then takes this steep plunging drop as journal rank decreases. It eventually just hits the floor on the right side. To put exact numbers to that visual drop-off we just saw, if you look at the top 50 highest-ranked economics journals, a staggering 68% of them charge a submission fee. But look at the bottom 50 journals within that 500-journal frame, a mere 2% charge a fee. So the data tells us that submission fees are, quite definitively, a mechanism utilized overwhelmingly by the elite top-tier institutions. And among those journals that do have an established price, the median converted fee sits at $143. But I want to offer a quick word of caution here. It is a really common mistake to think this $143 just goes straight to the referees to buy more review capacity. It doesn't. Because a massive number of papers are rejected right at the desk triage stage and never even reach a referee, fee revenue per submission is fundamentally different from a payment per completed referee report. Let's dive into Section 3, Tracking Rising Submission Costs. So are these entry prices actually going up? Are they going down? Or are they staying flat? By comparing 32 matched journals that had comparable posted fees between 2019 and 2026, the historical trajectory is undeniable. Look at those upward sloping plumb lines. Those indicate journals that raised their prices. You can see a massive cluster of them. 23 journals in total raised their nominal fees. And look closely at the top. Some of those lines reach upwards of $500, $700, and even $800. Now compare that massive sea of rising plumb lines to the single lonely blue line sloping down. That's the only journal in this set that lowered its fee. The gray lines, they just remain flat. So the historical direction is undeniably pointing towards significantly more expensive submission attempts. Now, we also see structural differences depending on who actually owns the journal. Based on the census data, publisher architecture seems to matter quite a bit. Elsevier and Wiley have a 34% and 32% incidence of charging fees, respectively. Springer Nature, on the other hand, sits way down at just 3%. Now, it's really important to note that we are just impartially reporting the data here. These are descriptive associations, they are not causal effects. Journal rank, ownership structure, and institutional subsidies are all deeply intertwined here, which proves that the sticker price is really only half the story.
That brings us right into Section 4, time versus money.
So far, we've only looked at the hard monetary data, but the financial part of the entry price only paints part of the picture. The absolutely crucial point here is summarized perfectly by this quote directly from the paper. A journal that rations entry with a long wait needs a smaller fee to ration the same queue. Think about that. Delay isn't just an inconvenience. For a researcher, it delays their tenure, it uses up their precious time, and it literally shrinks the present value of the prize of publication. Time is a cost. Breaking down this marginal price visually reveals two very distinct shapes. Look at the horizontal axis. We have the journal's report capacity divided by potential demand. The vertical axis represents the total marginal price required to clear the queue of submissions. Now notice how the total price is split perfectly into two components. That gold rectangle sitting at the bottom, that is the unavoidable burden. It's the price paid entirely in time, just by waiting around for the journal to make a decision. The dark plum triangle layered on top of it is the residual fee collected in money. So if a journal has very low capacity, over on the left, the money fee has to be high to keep submissions away. But as capacity grows, moving to the right, that plum triangle shrinks until it hits absolute zero. At that point, the painful wait time alone is enough of a price to deter excess authors. So, just to summarize that economic model, time and money substitute for one another. Inferring a journal's congestion solely from a high-dollar fee is a huge mistake, because it entirely ignores the massive invisible cost of a one-year decision delay. Waiting clears the queue, the financial fee is just whatever's left over. All right, Section 5, the submission cascade. Now we need to zoom out a bit. We've looked at what happens at a single journal, but authors don't just throw up their hands and give up when they're rejected or priced out. When an author's manuscript is rejected or priced out at a top tier, they face a continuation decision, and most of the time, they just move to the next tier down, submitting the exact same manuscript to a slightly lower-ranked journal. This means the demand for referee reports wasn't actually eliminated at all. It was simply transferred down the academic chain. This creates what the paper defines as a submission chain multiplier. What is that? Well, it's the expected number of total submission attempts generated by a single manuscript. Because papers cascade down the rankings, one single research paper can strain multiple distinct review boards across several months or even years. It's a massive ripple effect. Mathematically, this cascade compounds rapidly across journal tiers. If we assume a 50% continuation probability, which just means half of all rejected authors decide to try again, we see these descending solid plumb bars. 100% of papers hit their first choice, 50% cascade to a second choice, 25% go to a third, and so on. Even with half of the authors giving up after every single rejection, the math results in 1.94 expected attempts per manuscript. And check this out, if authors never give up, which is represented by those outlined bars hitting the ceiling across all 5 tiers, one paper demands 5 entirely different sets of referee reports. Finally, let's wrap up with Section 6, system-wide publishing pressures. Bringing all these theoretical and data-driven concepts together, how can the system as a whole manage this cascading pressure, especially in a world where AI is rapidly accelerating manuscript generation? Well, journals have several institutional levers they can pull to manage the congestion. They can offer low-income country waivers to ensure fees don't entirely lock out less resourced authors. They can alter when the fee is actually collected, charging it upfront versus making it contingent on acceptance. They can invest heavily in AI-assisted desk triage to filter out papers before they ever reach human referees. Or they can try to artificially increase capacity by offering paid referee honorariums. Now, each of these levers changes the math of the cascade in a totally different way. But that brings us right back to the core thesis of the paper. When a fee does none of these things, it passes congestion down the ranking. This is absolutely crucial to understand. If an upfront submission fee at a top journal doesn't make an author completely stop or shorten their submission chain, it doesn't actually save the scientific community any work. None at all. It merely exports the congestion away from the elite journal and dumps it squarely onto the desks of lower-tier journals. Which leaves us with this final, somewhat provocative thought to ponder today. As the absolute flood of research continues to rise, we have to look closely at the financial gates being erected at the top. Does a $1,430 submission fee actually buy the scientific profession more careful, expansive peer review? Or does it simply buy one single elite journal a slightly shorter queue, while the rest of the academic ecosystem drowns in the cascade? It's a question that really challenges the underlying mechanics of how we validate human knowledge. Thank you so much for joining me on this explainer, and remember to keep questioning the systems around you.